Hello, everyone. Welcome to Chars, a podcast about biochar, plural, sponsored by Byron Biochar. I'm your host, Don Coyne. Today, we're literally going back in black, not garden charcoal this time, but rubber from our roads. Every year, millions of tonnes of cars, tractors, and mining equipment end up shredded or shipped offshore to be burnt or disposed of erroneously. But what if those same tyres could be turned into a clean, stable carbon material and used to build better roads right here in Australia? Joining me to explain is Dr. Alexandru Lett from State Asphalt Services, a technical leader who's been trialling carbonisation methods to produce char from crumb rubber with very promising results. So welcome to you, Alex.
Thank you for the introduction.
So look, we'll get straight into it, Alex, and just to kind of cover your background and give a bit of context. Can you please tell us a bit about your journey and also how you came to work with State Asphalt Services?
Yeah, look, my background is the chemical engineer.
Yeah.
I graduated a PhD in chemistry with Melbourne University, and since then I work in the construction materials. I work almost 10 years with Boral in the asphalt and concrete. Then 2018, I started work in State Asphalt as a technical manager. And since then, I'm working with an asphalt industry, and I'm trying to bring in the asphalt recycled materials like plastic with biochar and char from crumb rubber. Okay. And before char, I use the crumb rubber to modify the bitumen with crumb rubber, 30 mesh size. Because the crumb rubber can be used like additive in the asphalt industry to be used like in the wet or dry process.
Okay. So when was that? When did you first come across biochar and specifically
the biochar? I started biochar 2011 when a Spanish biochar business come in Australia, and they come with biochar and some bio oil to see if it can be used. Can be used in the asphalt industry.
Okay. And so what sparked that idea to test carbonized rubber?
Look, the rubber, it was later on the rubber used in the asphalt industry for spray seal. In the countryside, Australia, the road is made using the spray seal crumb rubber. The crumb rubber first made on the 18%, it's 8 in the bitumen, stay half an hour in the mixer, then it's spray on the road.
Okay. 18%, was it? Yeah.
Yes.
Yeah. Okay. All right. And that's within that sprayed on product.
Yeah. On the road. Okay. But it's a crumb rubber. It's not
biochar, but
char, it's crumb rubber.
Okay. All right. But then how did sort of biochar get cut, or tire char come in?
Here's the char from crumb rubber.
I see.
Few months ago, I started to use, based on the information which I get from Europe, from the Biochar Summit 2025, where I attended in Brussels.
Yeah.
In June this year, I noticed the big issue. It's the biomass, availability of the biomass on the market to make the biochar.
Okay.
And from my perspective, with the biochar will be like a biochar from biomass to be used for the agriculture, and
Yes. Okay.
plastic or crumb rubber char to be used in the industrial area.
Okay. Yeah. So yeah, we must make that distinction.
Yeah,
Biochar is coming from biomass, organic materials, whereas tire char, is coming or crumb rubber. Of course, there's the rubber plant, but there's other synthetic materials in the
yeah,
tires. So we wouldn't specifically call that a biochar. We refer to it as a tire char, or sometimes called a synthetic char. But what you're saying was that the attendance of the Biochar Europe conference
yeah,
recently, that sparked the idea to test carbonized rubber in asphalt mixes. Was it? Yeah.
yeah.
Yeah. So, all right. And so, distinctively, this is what we're working towards with the development of the Australian standard, is having those, the tire char would not fit into that standard as such because it's a synthetic material. And so, we must make that distinction. But this is a huge problem nationally, and that's why I wanted to address it with you, Alex. I mean, millions of tons of rubber that is still has carbon value locked inside. So let's look at how big that opportunity really is. Roughly how much off the road tire material is generated in Australia each year that you're aware of?
Look, before to go, I want to specify that this char can be tested and analyzed in the same way like a biochar.
Okay. Yeah.
Then, based on the results, to be uh, uh, named char for industry area and the biochar for the fertilizer or bio production.
Okay.
Because in the end, we have to do the testing, everyone to be tested in the same way.
Yeah.
Because you know what's happened, you can see then I have some results. They behave different in some on the infrared testing. You get different results.
Okay.
But I think it would be better to have some control on the char or biochar to have the same testing than
Okay.
based on that not to be. Because I'm telling you what's happened, if you don't have control on the same testing, the people who make the char from crumb rubber or plastic, then they can call biochar, and you are going the other way, which is became poison for the animals or for the fertilizer in the
Yeah.
agriculture industry.
Yeah. So, okay. Yeah. So making that distinction,
Yeah.
that's great. Yeah. Standards, it's all about the standards. But the idea is, we're trying to match the feedstocks, which have some contaminants in them. They're synthetic materials. We don't want that going into agriculture. But so roughly how much off the road tire material is generated in Australia each year, Alex? You have
Look,
those?
at this stage, there are some uh, production with crumb rubber on the asphalt industry. Um, the tire stewardship, which is association which collect the crumb rubber, the tires in Australia, they come with the different programs in the asphalt industry to use the crumb rubber in the asphalt.
Okay.
The issue with the crumb rubber and asphalt, it became too viscous, and people doesn't like to be used because you have two things. It's viscous in the plant and make it harder for the binder with clam rubber to flow in the plant from the storage tank to the mixer. And the other things is the smelling because you have to heat up 180, 190 degrees when the clam rubber starting to release the smell from the black carbon and the sulfur which is inside of the clam rubber.
All right. So, where does most of
Yes.
where does most of the crumb rubber end up at the moment, or the tires
Look,
themselves?
I understood. I think in the Australian doesn't have a control on the clam rubber.
Okay.
Because I'm telling you, I have some projects, research project with Western Sydney University.
Yeah.
On asphalt, and they complain they don't have enough clam rubber, and they bring clam rubber from overseas to get the rubber for a playground for the kids.
Okay.
And when I talked with one professor there, and I told, look, if you want clam rubber, let me know. I have a lot of business which has the clam rubber, and they don't have what to do with the clam rubber.
Okay.
And he told me they don't have this information. They have information from the Australian government if they need clam rubber to go overseas to bring the clam rubber. It's a little bit hard to know exactly how much clam rubber is available on the market. But clam rubber to be used in the asphalt industry can be clam rubber from car tires, clam rubber from trucks,
Yeah.
clam rubber from conveyor in the mining industry.
Yep.
And I think the mining industry will be the biggest supplier in the end of
The mining.
clam mining. Yes.
Yep.
And
Okay.
think about
Yep.
if we can organize with them, look, you bring clam rubber, we can give you the asphalt to make your road inside of the mining and around
Yep.
the mining.
Circular, taking their waste streams and putting
Yes.
it back into their own infrastructure would be I guess that would change the sort of environmental and economic equation for them as
Yeah.
well. So so in asphalt terms, what materials could the tire char replace or enhance?
Look at this stage, clam rubber used like a clam rubber in the asphalt. It's improved the elasticity of the asphalt and improve the life of the asphalt on the road.
Okay. The life as
And,
well. Okay.
yes, but if you make a char from the clam rubber, that char can be used to modify the binder, the pitchment, on different grades, from the softer binder to harder binder.
Okay. Okay, that's
Which
right. Mm.
on this stage now, it's a use oxidation procedure. What means the softer binder pitchment, which is 170 per pitchment, is keeping the under heating and the high temperature for a few days to oxidize, then to get a stiffer binder, 600 or higher than 600 pitchment. With char, you can use around 5% on the softer binder, and you can get what grade of the pitchment you want. It's been you make a big difference in the electrical power used for gradings. From 24 hours electrical power used to oxidation of the binder, you get a few minutes, half an hour.
Okay. Yeah. Right. And as far as released emissions, is there any concerns there that the
As
emissions
char,
from
you
the
don't have
pyrolysis project? Mm.
if you use like a char, you don't have any emission from the product. It's clean, can be used
Okay.
safe. Only that chart should be encapsulated or found a way to be used in the plant because it's very fine, and when it's fine, it became it's not safe for the asphalt plant.
Okay.
But it will be the second point on the mass production of the char.
Okay. So, all right. So, because of that, yeah, oxygen anaerobic process, we're not getting that release of fumes that we would if they were burnt. Yeah.
No.
So yeah. So I guess yeah. So once that rubber becomes a char, what does it actually do inside the road? So let's have a look at that,
Look,
Alex. Yeah.
improve first improve the quality of the bitumen,
Yeah. Okay.
improve the quality of the binder which used in the asphalt.
Okay.
Then the second, improve the strength of asphalt.
Yeah. Okay.
Um, give you some flexibility in the asphalt. And the third point, increase the life of the asphalt on the road
Yeah.
because the oxidation by radiation from sun, it's reduced. And the testing and the lab testing show us a big reduction in the oxidation of the bitumen.
Yeah. All right. So they're the three main points there. So yeah, okay. And how does the char behave compared to traditional crumb rubber or fillers?
Look, now I'm doing some work to work with both of them.
Yeah,
To use the traditional one
yeah,
on the same time using the char on the same
char.
bitumen.
Okay,
To check what is the improvement because in the end will give you some improvement on the structure of the bitumen because the char of the crumb rubber acting on the molecule level on the inside of the bitumen, and the crumb rubber we use now on the asphalt. It's
yeah,
acting like a physical reaction between the bitumen and the crumb rubber, which improve the elasticity of the crumb rubber.
okay, yeah. Um, so are you observing any changes in mix temperature or compaction during the laying down, during the lay down of the?
Yeah, yeah, yeah. Can we talk about reduce the temperature? Because with the normal crumb rubber, the bitumen now, everything is done at 180 degrees.
Okay,
Compaction, everything. Because if starting to cool down, you lose the compaction. You can't do the compaction of the field. But with the char, you can get normal temperature like 140, 160 degrees compaction.
okay. So lower
Yeah,
temperature. Okay,
yeah,
which is better, less energy required. Yeah.
yeah.
So yeah, all right. And what kind of testing or data are you collecting to validate these results,
Look
Alex?
at this stage. I'm doing testing on the bitumen to test all the properties of the bitumen according to the Australian
Yeah.
test method and
Okay.
the American test method as well.
Okay.
I'm going with both type of the testing because they're using different equipment,
Yeah.
and the American one is more performant and more scientific than the Australian one, which the Australian one is a little bit older style
Yeah.
than the American. And then I'm doing some work on the asphalt to characterize the asphalt with Australian technical test method to
Okay.
compare with actual mix which already is doing in the lab
Yeah.
and the plant.
Okay. Okay, great. All right. And of course, it all starts with the feedstock and the technology that turns into char in the first place. So moving to the feedstocks and technology that's available. What types of rubber have you worked with so far? Is it car, truck, agricultural, mining, conveyor belts, etc.?
Look at the asphalt. I use truck and car
Truck
tires.
and car. Yep.
I didn't use the conveyor
Okay.
at this stage. And on the char one, I use the tire from car at this stage. Now I'm a part of the grant, which we are doing the uni more testing, which I want to prepare a experiment map to test everything. You know, the tire from car, tire from truck,
Yeah.
conveyor, tire from mining cars,
Okay.
to compare to get the results to see how we behave, and even to develop a map to show if there are any combination between each of source of the tires
Sort of
to
different
to
sectors.
found
Yep.
a way to improve the asphalt.
Okay. All right. So, how does feedstock composition affect the char yield or quality that you can see so far?
Look, the difference between truck and car tires is the percentage of the natural rubber.
Okay. The
Um,
percentage. Yeah.
yes, and this make you the difference. But the rubber from convert, I think it's big difference between them, and from that side, I'm more interested to see how behave.
Okay. All right. And could you walk us through how a modern carbonisation or pyrolysis system handles this material and how it differs from, say, incineration or gasification, which seems to be what's happening overseas?
Look, overseas, their system make char from gram rubber.
Okay.
They are doing bio oil and biodiesel.
Yeah. Okay. Yeah.
Uh, then they adjust the production, depend what they require to have more. If they want more biodiesel, they make the bio oil to be more raffinery on the plant to get more biodiesel. If they
Yep.
don't need, they claim from the percentage of the final product they require for the market.
Okay.
The bio oil, I have discussed with one business which they have a plant from a gram rubber. They are doing char, bio oil, and wire. Because the wire from tires, the guy
Wow.
collect them and bring back on the metal industry the wires.
Okay.
And I have the bio oil, and the bio oil I'm 100% can use like a business.
Okay.
Only the idea from this one, you have to help the producer, the my supplier, to keep long on the system to remove all the bad chemicals which is in the bio oil to make more safer for the working in the lab.
Okay. So yeah, much more circular, utilising everything
Yep.
through these modern carbonisation or pyrolysis systems. So from your testing, what char properties look most promising for road applications?
Can you repeat the question, please?
From your testing, what char properties look most promising for road applications? What are the char properties that you're
Look,
looking?
I tested one really interesting. Doesn't give you the moisture. What I noticed is the biochar accumulates moisture inside of the pores of the biochar.
Okay.
Usually it's around 27, 30% moisture. Doesn't matter where you keep the biochar. What I noticed with this type of the chart from Kramraba doesn't give you the moisture.
Okay.
The
I
moisture
see.
is the normal limits, which make the more easier to be used in the asphalt.
I see.
Because when you add the biochar or char in asphalt, the moisture which is inside of the pores make the foaming process in the basement. Because the basement is 180 degrees. If you have moisture inside of the pores, the water from inside become like a vapors and then steam, which make bigger pressure on the basement. And if you don't have enough space in the storage tank, can be split over the tank.
Okay. Yeah.
But with this one from the Krambraba, I didn't see moisture content. I have the graph, I have all the tests. Doesn't show me to have the moisture,
Okay.
which I'm really happy because you don't need to pay attention to the flow of the steam of the water from the jar.
Yeah. Okay. All right. Yeah. So making the process simpler through the product actually just being drier, and I imagine would the surface area? Would I be right in saying the surface area is increased over sort of crumbed rubber when it's carbonized?
Look, yes, it's increased because you need to use a very, very fine particle from a jar
Yeah.
to be under 70 micron. And you need to be very, very fine grounded.
Yeah.
And but this without water make me happy to use on the asphalt. It's more safer.
Much safer. Okay. Great. All right, and so that's that leads into the next question, which is what standards or safety considerations come into play when using these materials commercially?
Look, doesn't matter you're using biochar or char, need to be uh, encapsulated in what I did sometimes ago, encapsulated in the recycled plastic. Recycled plastic keep inside the biochar, which then the asphalt can be melt and make modify the basement. Uh, Otherwise, should be make like the pellets or something, which I did pellet with other products. And, but all the char should be treated before to be used in the basement.
Treated. Okay.
Yes.
In what way?
You need to change the surface of the char, which make with some chemicals which make the char more friendly with the basement.
Okay. Right. Chemical.
Otherwise, otherwise you have the segregation uh, things in the basement, which has been the char will settle on the bottom of the basement, and you have issue with
Okay.
the quality of the product.
All right. Okay. So yeah, look, you've shown there that Australia has both the waste and the know-how. The next question is, how can we scale and lead the world? So if we go to, I guess, Australia's 2030 outlook, what does the future look like for tyre char on our roads by 2030?
Look, at this stage, only my business using something around hundreds of thousands of ton of bitumen per year.
Yeah.
And our business is a small business. We have only 3 plants in New South Wales. That's it. Think
Okay.
about the big players, which they have 3 plants in each state, but each state in Australia, I think they have maybe 20 plants all around Australia. And if you multiply, I don't know, to take 200,000 tons of bitumen per year for each plant, it means if you use 5% up to 10% charge from rubber will be huge amount of the rubber can be used instead to use the electrical power to do the oxidation of the bitumen.
Okay. Okay.
I know there are some people in the bitumen industry which is against to use char in the asphalt because they thought it's dust and you change the property of the bitumen because you use the dust. But my point is, if you can use something else instead to use the electrical power, I think would be better to use this jar.
Char. Okay.
One of the second thing about the gram rubber, starting from the fossil fuel. You start from the oil to get the gram rubber. Now you start from the other way, from gram rubber to get the bitumen, the oil.
Yeah. Yeah.
It's the same chemistry.
Okay. Yep. All right. Okay. So yeah, it's a better way, definitely a better way. But what barriers do you see? Regulatory, technical, supply chain.
Look, if we get approval from Environmental Protection Agency, this is the big hard for us to get the char on the asphalt industry.
Yeah.
Then the second one is to find a way to pelletize the char.
Yeah. Pelletize the char. Yeah.
Then
Okay.
I think that will be everyone will be happy to
It'd be better.
do it. And the price, the final price of the char from the char supply.
Yeah. Okay. That's the barrier. Yeah. Need to get
Yeah.
the price point
Because
right.
now, I remember when I start discussion with the business from Spain for the biochar years back. He gave me a price of $800 per ton of biochar. I told him nobody will use 800. Will
Okay.
be use $800 per ton when this biochar can be mixed with bio oil, to replace the the bitumen from the mix. Because every time when I told you have to replace the most expensive part of the asphalt to get the price you get on the biochar. Otherwise, if you use biochar like a fine or like a dust in the asphalt industry, nobody will try to use it because it's too expensive. The same thing in the concrete industry as well. Think about all the aggregates. In both, it's up to $50 per ton. Nobody will pay $800 per
Yeah.
ton to use a biochar or char.
Yeah. Yeah. Okay. Yeah, so the price is a barrier there, but yeah, that can be brought down as we scale up.
One scale up, and the second, I told you, if we try to use this char with bio oil to get the big.
Yeah, so the bio oil as well is
Yeah.
gonna help. So okay, could Australia become a regional leader in the circular carbon construction materials? Do you think?
Look, at this stage, I don't talk about the char. I'm talking about the biochar, which is owned Europe. They are far before us, in
Yeah,
front of.
Europe, yeah,
Yes,
long way
they.
ahead. Mm,
Yes, yes. I know. Maybe it's the money they European Union they put on the on the game, or because now at this stage they don't have biomass available in Europe to be used for biochar. They are looking the biomass from Africa and from Asia. Somebody asked me if I'm going in India with them to do the biochar and to help them to do the asphalt, to do the roads there in India. Because they told in Europe they don't have too much biomass available on the market.
yeah,
Uh, we have to be careful because I think the European is coming here to take our biomass, and later on we realize, wow, we want to do biomass, but we don't have uh, feedstock.
feedstock. Yeah, okay.
And yes, Australia can be. Look, from my things, it's biochar or char industry can be the future of the manufacturing in Australia.
Yeah,
If the political and the other agency will help us to make to become like a big manufacturing. Think
yeah,
about this one can be used on the stainless steel production, can be used in the agriculture,
yeah,
can be used in the construction material. And if we are doing the research, 100% can be used to make parts of in the car industry.
yeah. Okay, great. So finally, if you had the ear of the policymakers today, Alex, what message would you give them?
To listen to the people who make and use biochar
Yeah,
in Australia,
yeah, yeah,
because nobody wants to stay to white them, to understand them, to make the law, because we lose time, and
yeah,
they have to believe the people which has experience in the biochar industry and the user of the biochar in
yeah.
Australia.
Okay.
Because as you know, I told you a few times, from my side, it's a little bit strange. I can't use biochar from Australia, made here in Australia or char, but can use biochar or char from overseas.
All right. Okay.
I can understand.
Yeah, yeah. So okay. All right. Yeah. So um, this is about closing the loop on our waste streams. They can become valuable resources. The alternative at the moment is driving emissions, and so that's what this is about. Why not use it if we can use it? It's a new industry as well. So, but look, Alex, thank you for sharing your groundbreaking work today. Your team's results show that once waste can now become a resource, and that innovation on our roads can start with the very rubber that we once drove on.
Yeah.
And so for more stories like this, you can visit byronbychar.com.au or subscribe on Spotify and YouTube. Until next time, keep turning carbon into opportunity. All right. And Chars,
Yeah.
thank you.
Thank you. Thank you, Don.
Thank you.